Yeah, out the light. Okay, in the last few sections of chapter 4, we talked about how to graph quadratic functions in vertex form and graph in standard form. Then in 4.4, we looked at factoring. How's that homework coming along for you? I heard a lot of grumbling. I can answer any questions on that homework if you need me to after we get through with this section. I meant to do that beforehand. Internet's been running slow and it's pushing me, like I'm trying to get so many things done last minute. But anyway, we'll talk about 4.4 factoring. I did post, no, I didn't post solutions. That's one thing I was trying to do and the internet would not let me today, but I'll do that later. All right, in the section 4.5, we're going to be solving quadratic equations, quadratic functions by graphing, using square roots, and factoring. I'm going to show you how to either use a graphing calculator if you have one, or you can go to desmos.com for the graphing method. You're going to love that method. To me, that's the easiest thing on here. There's not a lot of work to do. You just type in an equation and go look at your graph or look at your table, and you'll find your answers from that. Usually quadratic functions play a part. I know, of course, gravity, for example, if you launch an object from a certain height or from level, you throw a ball, it follows a parabolic path, and that can be modeled with quadratic functions. And they're used to find out after an object is launched, how much time will elapse before it hits the ground again and come back down. I know pyrotechnicians like to use quadratic functions to figure out how far up in the air that this firework needs to go off, and then use time and then height. Quadratic function, figure out how much time. I mean, they put it on display, of course, and you see all these fireworks going off at all these different times. So there's some math involved in that. Okay, I'm going to show you how to pick out the method to use. Of course, you can use any method. Graphing you can use on any function that you want to. Any type of function, you can always graph on and do that. Square root, the only time you can actually solve by using the square root is when you have only x squared and you don't have an x term in your problem. And of course, you'll solve it just like you would an equation. You're going to isolate x squared, and then of course you know to undo an exponent of 2, you take the square root. This last part is what everybody tends to forget at times. Remember, when you take the square root, the square root of 4 would come out to be positive or negative 2. So always remember to put your plus and minus on the answer. Quadratic, of course, goes back to the exponent of 2. This means you're going to have 2 answers possibly. And at the top, what do you always have to make sure set equal to? All the quadratic functions have to be set equal to 0 to solve them. And I'll show you why on the graph. Has everybody got that first part down at least? Okay. Okay, second method, graphing. You can use, like I said, on any function. your x-intercepts are your answers. The x values or x coordinates of your x-intercept is the solution, are the solutions to your quadratic. Have you heard, maybe you've heard this before, that your x-intercepts can also be called zeros, roots? Have you heard that before? Okay. Well, know that for a parabola, the two places or two possible places where it crosses the x-axis, of course, your x-intercepts, are also known as solutions, zeros, or roots. And the reason they're called zeros, if you're on the x-axis, what's y? Y is 0 good when you're on the x-axis. All right, and you're going to use Desmos.com, or I'll show you on your, how many of you have a graphing calculator? Okay, all right. You don't have to have one by any means. I just figured some people do, so I'd show you how. Or you can use Desmos.com, and all you have to do is arrow over to your x-intercept and get your x value. You're going to have, it may not ever cross the x-axis. So sometimes that happens. So you would have no solutions. Sometimes you may only have one solution. It might just come down and touch the x-axis one time, or it may cross the x-axis twice. The factoring method, you of course factor it if possible, just like we did in 4.4. See if they have anything in common, or see if you have a trinomial to factor, or that will factor. If you don't have something that will factor and you can't use square roots, then you must use the graphing method. But how you factor, set each part equal to 0, and then you're going to solve each part. So we're taking it a step further from 4.4. In 4.4, we just factored it. Now we're going to set each of those equal to 0 and solve. Okay, now let's practice them. In number 1, solve the equation using any method you want. You have y squared minus 49 equals 0. Can you factor that? Okay, you can factor this. How? All right, well, let me back up. Make sure it's set equal to 0, and it is. And y, I heard somebody saying y. This is the what? Difference of squares. So the square root of 49 goes here. Y plus 7, y minus 7. Okay, all you're going to do from this point is see what value would make this 0. See what value would make this 0. Or do the opposite. Always do the opposite of what's with your variable. So what will y be if you solve this for 0? Negative 7. And then y will be what? 7. Math Excel asks you to list them separated by a comma. Okay, the other way that you could solve that, notice that this does not have a y term. So you could isolate y squared and then take the square root of it, and you would get positive -7. So that's the other way. And number 2. It's set equal to 0, so we're good to go. Will this factor?
No. Yes.
What do y'all think?
Yes.
How? Do you have, this is a plus sign at the end, so remember in that case, they both take minus, or the sign from the middle. Do you have two numbers that multiply 36 that add? There you go. Have a sign. So 6 and 6. So what is your one solution? Positive 6. That's what you get in both cases. So there's an example where you only have one. If you were to graph that on Desmos, it would touch the x-axis at 6 one time. Okay, let's look at number 3. What can you factor out of both of them to begin with? Factor out an x. And this is actually a cubic function, but it has a quadratic part. So if you factor out x, what's left? Okay. Will anything keep breaking down? You've got this as a factor. People tend to forget that, but will this factor? Yes, how? You got difference of squares. So one's plus, one's minus, and the square root of 25. Anything you factored out, make sure that you keep bringing that down to the next line. Now you have to go through, how many pieces do you have? You've got 3. So I have to set each piece equal to 0 and solve it. So if I set that equal to 0, x equals 0 is a solution. X equals what from the middle? -5, and x equals 5 from the end. Notice that you had 3 answers, and what was your highest exponent? 30. So usually that's the case, unless sometimes it happens to be the same answer in both cases. Okay, do y'all have any questions so far? If you what now? In Desmos? Let's see. It will show you, yes, across there. All right, look at this one that I already had in there because the internet wasn't working, so I wanted to make sure we had one. This is one that we're about to do. You're going to see that this will not factor. So notice that it is crossing the x-axis at these points. So all you have to do is just arrow over that and click, and it's going to show you, I don't think y'all can really see that, but it's going to show you 0.50. So x equals 0.5 is an answer. And then it shows you this 0.60. So x equals 0.6 is an answer. But let's type in that one that we just did. Okay, we found that it should be crossing that 0, and it is here. And let me arrow out. Oh, wow. Okay. Notice that we also found that what else was an answer? -5, and if you zoom in a little bit, you'll see it's passing at -5, it passes at 0, and it also passes at 5. So I told you the graphing method, you're going to like that the best, because all you do is just go type in your equation and you have it. Okay, number 4. What do you have to do first in this problem?
Make it equal 0.
It's got to be set equal to 0. And you always want to try to keep your x squared positive. So if I just subtract 15, then I'll have it set equal to 0. And the reason is, going back to the graph really quick, we already said, like, what does y have to be? In order for you to find those roots, zeros, or solutions, y has to be what? 0. So in essence, like this would really be like f of x equal, you don't have to write this down, would be 2x squared plus 7x minus 15. That's what you really have represented, is this function. But then when we set this equal to 0, we're saying, okay, y is 0, so we're on the x-axis. What are those solutions? Okay, for this, how do you check to see if this will factor? Do y'all remember that method we did to factor? Good. Multiply by 2. Take this and multiply it to that number at the end. X squared plus 7x minus 30. Now, to see if it'll factor, trying to figure out two numbers that will multiply to 30. Should they add or subtract to 7? If your last sign is negative, that means that you had to multiply a positive number times a negative number to get this negative at the end. So minus at the end, different signs, so they got to subtract to 7. Good, 3 and 10. 10 must go with your positive, because positive 10 minus 3 got to give you positive 7. You have to remember to go back and divide by what? 2. Good. Plus 5. Simplify any part that will. So I get x plus 5 here. What does this turn into? Good. 2x minus 3. So that was where we stopped at in 4.4. But today we're actually solving, and so make sure if it says solve the equation that you keep going from this point. If I say just factor, then you're done. Okay, so solve it. Tell me if you solve this, x will be what? What will make this 0? -5. If you set this equal to 0, then you've got to add 3 and divide by 2. So x equals 3 halves or 1.5. Okay, how do y'all feel about that one? Okay. Do y'all like this better than those like 3 equation, 3 variable stuff? I thought so. What? I was saying, I feel like it isn't like traumatic. Yeah, let's block that out. You guys are awesome. The first day when y'all walked in, I was like, this is going to be a good class. Okay, I wanted to show you one like 5. because when we get into 4.6, you're going to have to solve this particular method I'm about to show you. Okay, there's actually two ways you could do this. You could go ahead and use the FOIL method and get x squared plus 6x plus 9, and then you could subtract 9 and make it set equal 0. Or you can go ahead and get rid of this exponent of 2 first. All right, let's do that. Let's take the square root of both sides. You're left with x plus 3. I don't put a positive or negative here because I don't know what x is. So you don't say plus or minus x plus 3, but over here, you do say positive or negative 3. Does that make sense? Okay. Now, I actually have two equations. I have x plus 3 that's equal to positive 3, and x plus 3 that's equal to negative 3. Tell me what your two values are. Good. X equals 0 and x equals, do it again, -6. Your brain wants to say that positive 3 and negative 3 and say 0. Okay, on 6, this one, you have to do the graphing method. Can you tell me why? Why will this not factor? Okay, what are the only factors of 3? 1 and 3. And of course, 1 plus 3 or 1 minus 3, either combination will not make what? 5. So this one will not factor. Okay, I'm going to show you something kind of cool with Desmos on this problem. So this is what your graph looks like. And if we zoom in or arrow over, I don't know if you can see that, but in Math Excel, they're going to ask you to round to the nearest 10. So if you arrow over, that first x value, or one of your x values, is negative 0.7. The other x-intercept is negative 4.30. But if you go up here and just change y to 0, it'll also give you those values too. So you can type it in like that if you wanted to. But if you do y, that's going to give you the actual parabola. But if you say 0, it's going to show you those vertical lines going through those points. Okay, so for graphing, so it'll work out nice, like if it doesn't factor, because you just type it in. So x equals negative 0.7, rounded to nearest tenth, and negative 4.3. If you have a graphing calculator, you can go up to your y equals area and type in your equation, x squared plus 5x plus 3. X. Okay, so when you go to your y equals area up top, make sure that your plot 1, plot 2, plot 3 at the top are not highlighted. If they are, just arrow up, hit enter. Graph it, and then you up at the top above graph, you've got a table option. It's going to give you your table of values. So second, go to table, and then you you can actually arrow over to where, or you can hit y is 0 and arrow up, and wherever y is 0 is going to be your x-intercept. And then if you arrow over with your graphs, notice here, I don't know if you can see that, but it says y0 and it's going to give you your x. So you can just use your arrow key and go over and find it that way on your graph. All right. Anybody have any questions about the graphing part? Okay, last problem. Other day. You don't have to write this down, okay? So don't freak out when I put this up on the board. Okay, this is another problem where quadratic functions play a part in real life. Of course, you've all seen a pendulum. The only part that you need to write this function down, L equals 0.81 t squared. This function represents the length L in feet and time that a pendulum takes to swing back and forth. So there's a convention center that actually has a huge pendulum that's 90 feet long. And let's say if the pendulum is 90 feet long, then find the period. So L represents the length in feet of the pendulum. T represents the time of the period. So where are you plugging in 90 at? Good. You're going to plug in 90 for L. And we are solving, that should be 0.81. We are solving for T. So you have 90 equals 0.81 T squared. What 2 steps are you taking to solve for T? You can do that. That's going, then it's not, and then you can type it in a graph because it won't factor if you do it that way. And here, well, graphing is easier, but if notice that you only have t squared, you don't have a t. So if you just solve for t squared, then take the what? Good, the square root. You can either graph this one, of course. You can type it in decimals, 90 equals 0.81 t squared, and it will show you your solutions. 90 divided by 0.81. That gives you 111.11 rounded equals t squared. And okay, you get t equals positive or negative 10.54 seconds. T equals positive or negative 10.54 seconds. Tell me, what is your only answer though? Good. Why? Good. The only answer is the positive 10.54 seconds. Can't have negative time. Sometimes we wish we could go back in time. We wish we could take away 2020. Okay, you guys have any questions? Your assignment for this is on paper. Your next assignment this week is in Math Excel. But on the paper assignment, you'll see I've written out on your paper which ones to do. And it's also listed on your assignment link. But let me know if your internet, let me know how it is and I can go make y'all a copy. Or I can go make you a copy. What did I say? What did I say? I had the hotspot from my phone and it's been working fine after that. But then, I mean, our phone service is fine too sometimes.